In this video, I'm going to talk about net ionic equation worksheet. Net ionic equation worksheet. So besides the worksheet packet, there's a totally 4 pages, only because I want to make more room for you to do the work. So the questions itself has 11 questions only, but I make it 4 pages so you can have more room. So besides the packet, you need to have, of course, the solubility rule, the chart and the periodic table, and also your color pen. All right. So I want to talk about first is the concept that you don't need to print it out, but I need you to understand. Okay. So what is the net ionic equation? Net ionic equation is basically what exactly happened after the double displacement reaction is finished and what I need to concentrate. Okay, so let's say I have PbNO32 and the Ki, and they both aqueous. And when they formed the double displacement, the PbI2 was formed. It's a PPT. Okay, so the PbI2 is a PPT, and then the potassium nitrate is the aqueous. So in order for you to have the double displacement take place, we say that we have 2 criteria. One is the 2 reactants must be aqueous, so then they can decompose into ions. So these 2 are aqueous. Another criteria is the PbI2 must be, I'll put it this way, one of the product must be gas or PBT or water in order for you to say the displacement takes place. So PbI2 is a PBT, so this reaction takes place. And then we go ahead to balance equation. So what happened is when I put the NO32 in the solution, in the water, and because aqueous, it is soluble, so decompose into, because I have only 1 Pb and then 2 NO3, right? So then they decompose in charges. And then the Ki, I will have, I will decompose and I will have Ki, K and I decompose. So if I pour these 2 beaker into one, if I pour these 2 beaker into one, what will happen is the PbI2 will be precipitated out, as the insoluble product, which is the PBT. Okay, and they will precipitate out. And the potassium nitrate, they would not actually form anything. So they will actually stay in the solution, just like in and out, in and out. They will not combine together to form a product. So they will actually stay as soluble in the solution. And the PbI2 will be precipitated out. So when we actually do the lab, when we put these 2, like when we have a beaker with potassium nitrate and a beaker with a beaker with the lead nitrate and a beaker potassium iodide, when we actually pour them together to be one single beaker, and then it will filter out through a filter paper with the funnel on the top and then the flask on the bottom, just like when you guys do the filtration of the iron powder, sand, and salt. Okay, I will have my PbI2 precipitate on the filter paper, and that's what I want to keep. This potassium and the nitrate, they will go to the filtrate, they will go to the flask, and I don't want them. I don't care about them. All I care is what happened on the precipitation on the filter paper. So because the potassium and the nitrate, they remain dissolved, they remain soluble in water. Potassium and the nitrate, they are so-called spectator ions. They are so-called spectator ions because they remain soluble in water. They will not form like a compound. They will not form a precipitate. So they will not be included into my net ionic equation. What does that mean by net ionic equation is I only care about what happened onto the precipitate. So net ionic equation is after you take away my spectator ions, potassium and nitrate, exactly what happened is the lead 2 plus and the iodide minus, they will form PbI2 precipitate. This is called the net ionic equation. This meaning that I only care about after I do filtration, this part. So any other thing they remain aqueous, they remain soluble, I'm going to filter them out. I'm going to throw them away. All I care is something that I filter out onto the filter paper. So this equation is called net ionic equation, and I will care about this. Okay. So the step how to do the net ionic equation is First, I will give you like a equation like Na2CO3, for example, Na2CO3 and calcium chloride. And then if you check the solubility for using the solubility chart, they both aqueous. So first, you want to write so-called molecular equation. Molecular equation, okay? Meaning like the equation that you always do. You predict your product, which is PPT, aqueous, and then you balance them. So this is a molecular equation, ME, just like your regular equation that after you predict product. Okay, and then I found out that, oh, my calcium carbonate is insoluble, so I put down PPT. And then step one, okay, so it's regular do it. And then step two, you want to write so-called total ionic equation. The total ionic equation meaning that when I see aqueous, I'm going to start to cross over back to form the charges back, okay? But when I see PPT, or when I see water, or when I see gas, I don't touch them. I just leave it as it is. Anytime when I see aqueous, I form the charges back. And then I will remove the spectator ions because they will be showing up on both sides of the equation. The spectator ions will be the one that they're soluble, they're aqueous, and they will show up on both sides of the equation, and I will cancel them. So what happened is I form back, okay, I have 2 Na. Okay, see, I have 2 Na, and the Na is plus. So I write 2 Na plus AQ. CO3, I have 1 CO3. So I will write 1 CO3 to minus AQ. Make sure you have coefficient, the ion with the charge, and the state of matter. Measure 3 things. You have the coefficient, the ion with the charge, and the state. Okay, so when do I need to decompose this is when I see AQ because they're soluble. Right, CaCl2, when I form the charges back, when I cross over back, I have 1 Ca. Oh, Ca is 2 plus AQ. And then I have 2 Cl, so 2 Cl minus AQ, okay? And then because it's a precipitate, that means they already precipitate out. You can't touch them, so you just copy as it is. And I have 2 Na plus AQ, okay? And I have 2 Cl minus AQ. So this is so-called total ionic equation, total ionic equation. Then you want to compare on both sides. If both sides have the same coefficient, same charge, and same state on both sides, you need to cancel them. They are so-called spectator ions. If they have same charge, same coefficient, same ion, same charge, same state, you can cancel on both sides. So here, if you read, I get 2 Na plus AQ on left. I also get 2 Na plus AQ on right. Same coefficient, same charge, same atom, same element, same state, I can cancel. So cancel 2 Na plus AQ on both sides. If you did something wrong, you balance the equation wrong, you cross over wrong, okay, such that, for example, I only get 2 Na plus AQ, but here I only get 1 Na plus AQ, you cannot cancel because you did something wrong. You should stop and go back. Okay, let's say you have only 2 Na plus AQ, but here you have 1 Na plus AQ, you did something wrong. You cannot cancel. You have to go back, you check. How do you know that you can cancel? It must be the same number, coefficient, same charge, same state. Then you can cancel. So I can cancel the 2 Na plus AQ on both sides. I also can cancel 2 Cl minus AQ on both sides. Okay, and then step 3, you want to write the so-called net ionic equation, NIE. Okay, the net ionic equation again is like whatever left over that will bring me to the formation of precipitate. Okay, again, now how do I know that my aqueous, how do I know my double displacement take place? Is first, my 2 reactants must be AQ. And second, one of the product must be PPT or gas or water. So that ionic equations, whatever left over, they like after I cancel the spectator ions. So my spectator ions are Na plus and the Cl minus. I cancel them. So whatever left over is 1 Ca2 plus AQ and then 1 CO3 2 minus AQ, arrow 1 CaCO3. Okay. Then here I try to make it the positive go first, negative go next. Okay, positive go first, negative go next, because later we need to cross over back. But this is so-called the net ionic equation. Okay, so now let me jump to this worksheet. Okay, so this worksheet in this video, I'm going to show, let's see, I'm going to show question 1, question 2, And let's see, question 3 and question 4. So 1, 2, 3, 4 will be on my video. Okay. So the spectator ions are the ions that remain soluble aqueous in water and are not included in the net ionic equation. The net ionic equation is the one that after I cancel everything. So spectator ions are the one that I cancel, so they are not there. And the spectator ions show up on both sides of the total ion equation. They will show up on both sides of the total ion equation, the one that I cancel. And then they will have the same coefficient, charges, and state of matter. So then I can cancel them out. Okay, so then again, I have 3 kinds of the equation in this worksheet. Okay, so let me just take this whole thing. So the first kind is called ME, molecular equation. Molecular equation is actually the, I can show the notes here. Molecular equation is actually the formula equation. The formula equation that you're going to write, okay? The one that we always do. And the second kind is called TIE, total ionic equation. Total ionic equation is the one that you separate your charges. You cross over back the charges. You take the compound, you cross over back to form the plus or minus after separate charges, which is this. Okay, the total ionic equation is this one. The first one, this is a total ionic equation. Okay, so the first one is the molecular one, is the one that you write formula. And then the third one is NIE. NIE is this one. Is this one? Is after I cancel my spectral ions. Now note that the net ionic equation must be simplified. You have to simplify. So you might end up with a situation. Let me see. You may end up with a situation. For example, okay, you might end up with something like that. Oh, I got my, you don't need to copy this down, okay? You get for H plus, and then I got 2O2 minus, and then I will form 2H2O. You may end up with this situation after you cancel everything. This is not your final net ionic because the coefficients are not simplified, 4, 2, and 2. So they're not simplified. You have to take all the coefficients divided by 2. You have to divide by 2 to get 2H plus, and then 1O2 minus, and then you get 1H2O. This is your final simplified net ionic equation. So your net ionic equation, you have to check, is my coefficient all simplified? If not, you have to simplify because later on it will affect the checking work. Okay, so make sure they're simplified. Okay. And so this is the net ionic equation that you will get at the end. For example, this is an example, 2Fe3 plus Aq plus 3O2Aq to form 1Fe2O3 PBT. So at the end, you have 4 steps you need to check. So the first step is you need to make sure that the equation is balanced. Okay. Now, again, this title, 1, 2, 3, 4 titles, I will provide it to you on the test. So you don't need to remember what do I need to include. I will provide these 4 titles on the test. So after you get the net ionic, the first thing you need to check is my equation balanced? So you need to write down your atom, Fe and Cl. And actually, this is, I got something mistake here. Your Fe is not 1. Your Fe is actually 2. Okay, your Fe is 2 on the left, and then Fe is 2 on the right. Okay, and then my O, oh, I know what happened because I use another example. So this one should be O. This one should be O. The one that on your worksheet should be correct. Okay, the O, I have 3 of them, and then the O, I have 3 of them. So you have to make sure that the equation is balanced. It's balanced. Okay, checking the elements. And then number 2, you want to make sure that the charges, oh, I think I know what's going on because I modified my worksheet before. Okay, so you have to make sure that the charges are balanced. So for example, here I got 2 times plus 3 equals plus 6. Okay, and then the negative, I got 3 times minus 2, I also get minus 6. So this is equal to 0. So I don't know if you remember that, right? That step 1 is we're doing balance equation. And step 2 is when we're going back to unit 4, we do like checking the balance out of the equation, or how do I know that the compound that you write is correct formula? You check the plus, you check the minus, negative, and then add it up to 0. Okay. And then step 3 is if you have the crossover correct. So again, I have to fix this. I mean, the worksheet you get, it should be correct. So I got O2 minus here, right? So Fe3 plus O2 minus, I will get Fe2O3, which is correct. Okay, after I cross over. Okay, after I cross over, I get Fe2O3, which is the compound that I got, which is correct. And then step 4, I want to check if the double displacement reaction, the condition met, is the two reactant, okay, the two reactant must be AQ, okay? So my Fe is AQ, Fe3 plus AQ, my O2 is also AQ. That's the first condition. Second condition is my product should be PBT. So yes, my product Fe2O3 is PBT after the shadow solubility. So these all 4 conditions must be met, okay? And then again, when you have the AQ state, the AQ is soluble, so then you have to separate into positive AQ and negative AQ. And then when you have PBT gas or water in liquid, they are insoluble. No separation into charges, no charges, don't touch them, just leave them, okay? And then you want to show your total ionic and net ionic form of the following equation. And if the species are spectator ions, please indicate that there's no reaction take place. So I'm going to do 4 questions for you. Okay. So the first one. Okay. So I give you sodium hydroxide and hydrogen monochloride. So when I gave you is always AQ, okay? You don't need to check these two because whatever I gave is always AQ for the reactants, okay? If they're not AQ, then you don't need to do the work. But I mean, just go ahead to check, okay? Sodium hydroxide is AQ. So sodium is Na plus, and then monochloride is also AQ, would be Cl minus. And then I'm gonna draw a rainbow. Okay, when I draw the rainbow, I will bring them to the first cloud. So Na is plus Cl minus. And then here, I need you just write down the word. So all you need to do is just copy sodium chloride. You don't want to write sodium monochloride because this ionic, no prefix. We just write sodium chloride. And you can tell Na plus Cl minus, it is sodium chloride. Okay, we don't write sodium monochloride. You have to be careful, no prefix. Sodium chloride. Okay, and then green pen. Okay, I have hydroxide, which is OH minus, and then hydrogen will be H plus. Draw a rainbow. Okay, draw a rainbow. Okay, so then I will get H plus and then OH minus. And then I'm going to write, you know that this is water, but I want you to write the compound. So it will be dihydrogen monoxide. Okay, it's H2O, it's dihydrogen of 2 hydrogen and then monoxide. Okay, so you start to write for this now. Okay, next we're gonna check if each thing is aqueous and then is a PBT or liquid or something. Okay, so sodium hydroxide, we first want to write down the coefficient. Okay, write down the coefficient first, and then sodium hydroxide, you cross over, you know the formula is NaOH. And you know it's aqueous because we already formed rainbow, AQ. And then next is with the coefficient and hydrogen chloride, right? Hydrogen monochloride, if you cross over, you know that this is HCl and it is also AQ. And then arrow, okay, so here, sodium chloride, these two are aqueous, they always aqueous, the reactants are aqueous, I gave you. But then starting here, you have to check before you write, okay? Sodium chloride, if you check the solubility. Sodium chloride. Chlorides are soluble. Okay, so meaning it's AQ. Okay, so we can use red pen. Continue. Is NaClAQ. Okay, and then water. You know water is liquid. Water is liquid. So liquid, I will use, so like AQ, I use red pen here. If it's like water or gas or PPT, I'm using blue pen because they're insoluble. So since this is water in liquid, so I'm going to use blue pen for anything insoluble. Okay, so plus arrow, and they form H2O, and it's liquid. Okay, next, you know that this is liquid. Okay, you go ahead to balance it no matter what. In this worksheet, you go ahead to balance them no matter what. Okay, go ahead to balance them, even though you know that reaction may not take place because they're all aqueous. Go ahead to balance them no matter what. All right. So first of all, you know that I do have reaction. Okay, so I'm gonna use black pen to check. I do have reaction. Okay, and no matter what, you always go to balance. So after I balance them, I will get 1, 1, 1, and 1. Okay,